Okay. Now, and so moment generating function. Okay, for normal now. Okay. When x followed normal with parameter mu and sigma squared, f of s is 1 over square root of 2 pi sigma squared days x minus mu over sigma squared, and of course s lie between negative infinity and positive infinity. Now I want to obtain ms of t. The ms of t is exponential raised to power this, which is going to be integral this e raised to power tx f of s dx. Okay, for continuous random variable, this is the formula for moment generating function. You're actually going to put the state space for normal distribution. It's actually that guy. Okay, so right now I'm going to rewrite this as negative infinity to infinity e raised to power tx, okay, 1 over square root of 2 pi sigma squared exponential raised to power this x minus mu, okay, dx. Okay, if you don't understand, please ask question. You can also allow you to take a picture, and of course this is also being recorded. Okay, so take a look at that. I want to perform an antiderivative on this now. So breaking it out. Okay, so this guy, sigma, that guy is gonna be 1 over sigma square root of 2 pi. Okay, from negative infinity to infinity, e raised to power tx. I can combine that minus, okay, half, okay, x minus mu, okay, over sigma whole squared. Then I got the s. Okay, now I can do let z represent x minus mu over sigma. Okay, so what is going to be the z, the s, is 1 over sigma. That implies our ds equal to sigma dz. Okay, so if that happens, then I'm actually going to have this, okay, negative infinity to infinity, okay, and right now, if you take a look at this guy, this implies x, that implies s equal to c else that plus mu, right? Okay, don't forget I'm using substitution method, right? Okay, so e raised to power, okay, t, what is my x? Okay, my s is this plus mu, okay, minus half. The whole of that guy is actually z, okay? This is z squared. Instead of ds, I got sigma dz, okay? So see that, actually cancel that, okay? So when I cancel that, okay, I'm actually going to expand this guy. So I can put this guy, mu t divided by square root of 2 pi, negative infinity to infinity, e raised to power sigma, that, okay, minus half sigma squared dz. Any question at this time? Take a look at that. Is there any question? Look at where we are now. Any question? Okay, so, oh, okay. I think the time is kind of flying. I'm going to quickly do this. Okay, so if you take a look at this, okay, so n s of t e raised to power mu t divided by square root of 2 pi, negative infinity to that, okay, and I can do, if I pull minus half out, okay, I'm going to have z squared minus 2 sigma 2 sigma t z, right, dz. Okay, now if you take a look at this, I want to do something. Z minus sigma t all squared. Okay, what does that mean? That would be z squared minus sigma tz plus sigma t squared, right? I want to use that here, but this is actually is going to mean z squared minus 2 sigma z equal this minus that all squared minus this. So right here, ms of t equal this divided by square root of 2 pi, negative infinity to that, e raised to power this. So I can write z minus sigma t all squared minus sigma squared t squared dz. Okay, now when you take a look at this now, e raised to power mu t, so this guy plus sigma squared t squared over 2, then I'm going to have this, okay, 1 over this exponential half, okay, and here I'm only going to be left with this all squared dz. Okay, sorry for using additional 2 minutes. I just want to finish this. Okay, so when you take a look at this now, okay, if you let y be this, okay, the y, the z equal to 1 implies the y equal to the z. So if you want to write that, the ms of t equal e raised to power this plus sigma squared t squared, negative infinity to that, 1 over square root of 2 pi exponential half y squared dy. What is this? That is standard normal distribution, and integration is to 1. So finally, the moment generating function of a normal distribution anywhere in the world is this guy. Okay, now you know what I needed to do? Go and try it. When you differentiate it and you put 0, okay, that will give you your e of s. This is going to mu. When you differentiate again and you put 0, that would be e of s squared, which is going to be mu squared plus sigma squared. Okay, by the time you do the variance should be sigma squared. You can try that. And if you really want to know whether this is correct, I told you when you plug in 0 for t, it should give you 1. Plug in 0, that's going to be 1. Okay, so we're going to continue from here tomorrow. Is there any question? You know, theory of statistics requires knowledge of mathematics. Okay, I can do all this because I have a PhD in mathematical statistics, so I do a lot of math. And let me tell you, don't just be doing math. You have to understand what is behind every equation. I know the essence of doing all of this that I'm doing right now is to be able to have a generating function that will enable me to derive the center, okay, which is the expected value of s, the variance, because that is needed in statistical analysis. Okay? Okay, in the absence of question, make sure you all stay safe and have a lovely day. Bye for now, everyone.